there's this idea of batch processing versus stream processing. And so, what's the difference from a machine learning perspective between these two processing modes, batch and streaming? And how does that tie into reactive data processing?
So actually, the answer that would be taken from a reactive data processing perspective is that if you look at time as something that appears in your data. If time is an important feature for you, then it's an important feature for you, and whether you are in batch or in streaming, you should handle time. If time is not a feature in your data, then you should have the privilege of not looking at time, and the system will be able to handle things for you. So, just to give a very concrete example, let's take
Yeah, please.
yeah,
You just blew my
let's
mind.
let's
If
suppose
time, if you have the luxury of time not mattering.
yeah, and it's actually something like time not being a feature means that, for example, look at spam. What's a spam message?
Right.
A spam message is the same. Like you see spam, you recognize it, you treat the same thing as spam today as in a week or in a month. Right? It's spam is spam. It's like there's no time aspect related to spam. However, it might be the case that depending on how the spammer is behaving, you may be able to detect a spam message at some point or not. For example, when somebody is sending a message for the first time, the spam filter may still not be aware that it's spam. But after a message has been sent 10,000 times, 100,000 times, your model for spam detection or a spam detection filter will be able to figure out that something is amiss because of the behavior of the spammer. Your messages are classified as belonging to a kind of cluster component somewhere, which is spamish, and all of this can be classified as spam. Right? So, in this sense, what's happening is that the incoming data allows the model to improve its classification decisions over time. However, the logic of the classification process as such is largely not tied to time. It can be time doesn't have to play a role in it. You can do a lot of things without thinking about time. So what the answer is in a reactive setting is that you could imagine that you have access to all of your data in batch mode. Basically, you have all of the input. You process it. You give the answers, and these are the best answers you can have because they're answers given with all the knowledge. And then if you launch the same code in a reactive system, it'll be doing its best to maintain answers which are as good as possible given the current knowledge. So at the end of the day, it will converge to the same outcomes which you would have had if you had had all the information initially. And on the way, it'll be doing kind of a best effort classification based on whatever partial knowledge it has. So it may happen that a message comes into your inbox, call it Gmail, for example. Suppose Gmail has a reactive spam filter. It's classified as non-spam, but 5 minutes later, when new information arrives, it becomes automatically reclassified as spam and can be pulled from your
Oh,
inbox.
wow.
So this is the idea that you don't have to worry about the deployment, the way how things are going to be, run, rerun. You don't have to worry about how the data streams unfold over time. You just design the logic and you put it in the system, and you are released from the worry of the streaming data.
Cool. All right. So I know we're getting there, but so how does this? How we haven't like concretely defined this difference between batch
Mhm.
and streaming.
Yeah. So batch is the concept that your computation is run and scheduled. I think batch, orchestration, scheduling, these are concepts that all go together. They're part of the same mindset. It's one where you look at the data as it is now, you run a computation on it, or you run
Right.
some processing on it, something happens. 8
Right.
hours later, 24 hours later, the scheduler says, rerun the batch, you rerun the batch, and things get updated. So it's
Right.
this type of mindset.
To give maybe an extreme example that gives a clear sense of this, when people have been using ChatGPT since it came out in late 2022, it it has a modal that comes up and gives you all kinds of warnings, like this is experimental. But one of those warnings is that the data hasn't been refreshed since 2021 or something like that, and that's
Mm.
because the underlying model. So up until very recently, at the time of recording, the most common natural language model that people were using under the hood of ChatGPT was GPT 3.5. And this GPT 3.5 had been trained on a batch of data that was current up until 2021 at some point. And so there was this big batch of data, and then it took, who knows, maybe weeks of training, maybe even months. I don't know. GPT 3.5 was so large that the whole processing pipeline could have taken months to do, particularly when they want to add in all these kinds of safeguards around using it ethically. Um, and so that model is not streaming. It's very much the opposite. And you could take that same model architecture and update it in 2022 at some point, but it's only getting like this annual update on a batch basis. So you have these big batches of data, and so you're describing a situation where the batches could be much smaller, where it could be every 8 hours or every 24 hours that we have a machine learning model in production that is where the model weights are being updated from new data, so that things like a new hub in the delivery network that came online in the last 24 hours is now going to be handled. We have some data regarding this hub, and we can be handling it. Yeah, this kind of gives a sense of batches and how we can have big gaps between model refreshes or small gaps. And then streaming is a completely different kind of perspective where it's like data point by data point in real time being updated.
Yeah, streaming is exactly this perspective where the data flows in a manner where when a new data point comes in, you handle it. So if I think like to be perfectly like to take a maybe a human perspective on batch and streaming, the inherent preference for looking at batch or looking at streaming depends very much on what world you come from. If you're more in the mainframe or static database type of thinking, you probably have a natural preference for looking at computational systems as batch systems. If you are more in the microservice design, APIs, things communicating, data flowing, your natural preference, your first approach is more around working with streaming data, and the for each type of system, whether it's around batch processing or around event-driven stream processing, has very different characteristics. In general, being event-driven has the obvious advantage of lowering latency because you can react to new data as it arrives, so your models can update. The difficulty is in making non-trivial logic work. And by non-trivial, I mean actually doing something like a database join, which is already impossible in most data processing frameworks to maintain a join of two data tables. Join as you would see it in SQL or in Pandas or whatever. This is something that's hard to do in real time, let's say, and that requires a special framework which has to know how to handle a join to be able to do it. So back in 2019, it was messy to do. Now more and more frameworks are catching up. But this is about the forefront in terms of tooling as what's possible, what kind of difficulty of processing is possible in real time.
Cool. Yeah. So it sounds from, I come from this uh from this background of being a scientist. And so we ran discrete experiments and you get a batch of experimental results. And so I'm used to this idea of having like this specific table where, like, okay, experiment one is done. I have my set of data. It has this many rows because that's exactly how many human participants we had in this first study. And then it's just kind of static indefinitely. And I train a model on it, might and publish the results of the model. I might even make the data open source, make it available freely online, put it into the public domain, and then anybody can use my perfect table of data from experiment one that never changes. Um, and so yeah, so I come from um, this batch background. It's probably the case that people that are used to the kind of streaming situation that you're describing, people who are used to microservices, they're probably more likely to come from a computer science background or a software development background.
So I can give you an example because right now we're doing some experiments on our side. We're running benchmarks of Pathway against other frameworks. So we're doing an experiment, and in if in some sense these experiments, let's say, last weeks, they take weeks to run, and you need multiple repetitions of an experiment to get reliable data to be able to take, let's say, the median of the data points or some average or whatever. But imagine you just wait for the first run to complete, the first run of the experiment. And you already have a data source, which can be like, let's say, Google Sheets or Excel. And Google Sheets is a better idea, gives a better idea because it's kind of more online, more live, where you've put your experimental results there. And at this point, you can use whatever plotting software you like, let's say Tableau, to get some first uh, first charts out of it. And now suppose you continue running the experiment, and as new data points arrive, you get a larger and larger sample, and your dashboards are live, they get updated as the sample grows. And for example, once you've got 5 runs, a line which was a bit noisy at the beginning has kind of smoothed out because you've lost the statistic noise level has been reduced. So your dashboard is a kind of live dashboard on top of a scientific experiment. So in some sense, in this way, you can look at a scientific experiment being done in streaming mode. The new data is coming in, it's updating, fixing the dashboards, and at some point you press stop, and this dashboard is production ready. And this I think is a good point to say that the fact that you're in streaming mode does not mean that you cannot look at data back in time. It's a bit like with most of our productivity tooling that we're using these days. We're used to the fact that you can look at the version history, you can go back some number of edits, you can go back to a past snapshot, a past version of the system. And this is especially important in distributed systems which are serving answers to requests, and you have to be absolutely sure that you are serving answers based on a consistent version across machines, meaning that you're referring to one snapshot, let's say from a few seconds, few minutes back. But if there's a problem with a snapshot, you could also roll back to a past snapshot, maybe 20, 30 minutes back, or even further. So there's a kind of notion of snapshotting of the past, but you're working inherently with a kind of timeline of things that move forward.
So is this constant movement, this constant timeline, is that maybe the most challenging aspect for machine learning engineers when they're trying to implement streaming applications?
If you were using an API which has streaming in the name, then it's an added challenge. It's a second challenge. I wouldn't want to say it's the biggest challenge in terms of uh, some kind of ingenuity being conceptually the most difficult. That would be undermining the effort that's needed to actually get something going in machine learning, which is enormous. But it is an enormous challenge in terms of system deployment system maintenance, making sure there are no bugs, making sure this is actually feasible to run. So the industry standard for now is that going from batch prototype, that means static data, data scientists showing a dashboard, to a live streaming deployment of the same dashboard updating in real time, is roughly 10 times the effort. So I'm not saying it's necessarily 10 times the same ingenuity needed, it's just 10 times the effort, at 10 times the timeline likewise. So it's a question of cost. It's a question of some R&D risk involved, some risk that things will go wrong or that will not be moving fast enough. And afterwards, there's a question of maintaining this and making sure the system is going. So at this point, the system, if it's a streaming system, it has essentially hired somebody on the MLOps side, on the data and engineering slash reliability side to make sure that the pipeline is being properly maintained. So it's a challenge to the degree that many systems never end up going from batch to streaming or from prototype to production with real time data, because this challenge is just too much to overcome. And depending on the setting, it sometimes may be the case that the project actually brings 10 times more value if put into place in real time, or even more. But it just never happens because the cost side is too prohibitive, or the timeline is too prohibitive. And
Right.
the approach that we're taking is basically to automate the second step, make this
Right.
possible too.
So streaming can historically be 10 times as complicated, uh, but it can offer more than 10 times the value once it's implemented in production. And real time reactive data processing frameworks like Pathway are designed to dramatically decrease that 10 times complexity in getting it set up and allowing you to realize that 10 times value.
Well put, John. The cost, the cost aspect is actually quite fascinating because as we do this transition from batch systems to work more and more with streaming data, there are a lot of dimensions on the cost side which come in with a streaming system, which are not obvious. So one aspect is that the structure of expenses related to infrastructure, cloud infrastructure, changes. Traditionally, streaming systems had a higher hot storage component, requiring a lot of state to be maintained in hot storage, and this is only changing now. This is a cost factor which is being reduced, and this is the counterpart is actually that batch systems have an enormous computational cost associated with them, because you are
Hmm.
doing a lot of essentially useless computation. Every 24
Hmm.
hours, you're recomputing the same things, even though maybe in the horizon of one day, 1% of your input data changed, you're doing a
Right.
100% recomputation.
Right. Right.
So in the case of of actors, when you look at your cloud bill and you take the three components, which is storage, data processing, and networks communication, let's say, if the data processing clusters, your Spark clusters or whatever else you're using to churn the data, are generating a significant part of a bill, it may be the case that moving to streaming like systems or reactive systems which allow you to transition through micro batching into this online world will actually cut the bill of the deployment.
Cool. Yeah, that's really interesting because to me, it seems inherently that if you have this continuous learning, oh, of course, that's going to be more expensive because it's always learning all the time. But I hadn't thought about it from this perspective that with batches, you're retraining the entire model every time.
Yeah.
And so that is very computationally expensive. Very cool. Hadn't thought about
There's
that.
there are many like practical aspects to it, and one is just it's the reality around us that ad hoc instances are often much more expensive than instances that are reserved. So the rule of thumb is that if your computation is running for 4 hours, 5 hours, 6 hours during a day, during 24 hours, it really makes sense to have an instance just reserved for this like 24/7 without asking for a new instance every time. And if you're in this space, by making this like batch computation spread out over time, you are already better allocating your resources, because you get something like a factor of 4 or 5 in computational resources for free, just by having more hours in the day to use. And there are a lot of possible gains which just come from this better like spreading of computation over time.